So this is, we're talking about Groovy for system administrators here. In this presentation, we're going to be discussing how we can leverage Groovy in the infrastructure to help ameliorate the job of system administration to make it easier for us. Now, like I said before, and I'll say it again, I did tweet about this, and if you guys are looking for a talk on how to replace your bash scripts with Groovy scripts, this is definitely not that talk, 100% not that talk. We can all figure out how to execute processes, run system commands with Groovy, so I'm not going to be covering that at all. We're going to be going a little bit deeper than that, and we're going to also be covering some of the conceptual conversation around what it means to be DevOps these days and what it means to be a system administrator and how we can kind of utilize Groovy in that newer role to make our lives much easier. So who am I? I'm Dan Woods. Hello. Like I said before, I write for InfoQ. I'm an author for InfoQ. I write on the Java and JVM ecosystem. Things that are interesting in there. I've written about Spring and Spring Boot. So I have some good articles on that on InfoQ. You guys can check it out. If anybody's interested in writing about Java and JVM technologies, feel free to reach out to me. I'll get you connected. I'm on GitHub. The code for this, all my past presentations, all future presentations will be available on my GitHub. That's github/dandeveloper. Sometimes, infrequently, I tweet about things. I'm pretty sure everyone here follows me on Twitter. I recognize all your faces, but in case you don't, it's @dandeveloper. And you guys can reach out to me via email directly if you have any questions about this or anything else, danielpwoods@gmail.com. Feel free. I love getting email and solving problems with people. And in my free time, I code for Netflix. In addition to that, I'm a Red Hat certified engineer. I'm also a Red Hat certified network security expert. A lot of the content of this talk is going to be centered around CentOS, which is a RHEL derivation. So don't be angry if you guys prefer Ubuntu. That's just where it comes from. So this talk, like most great talks, is built on the ideas by a brilliant computer scientist. And I feel it prudent to start with a quote from that guy because it'll kind of set the stage for what we're going to cover. And it goes something like, system administration is a multifaceted problem domain not dissimilar from software development. So it's important to understand that when we're talking about system administration, we have the same kind of problems to solve in that problem domain that we do with software development. So that's kind of, I think, a good way to get your head around what it is that we're trying to do and the approaches that we need to take to understanding and solving system administration. And we could break system administration down into sort of 3 top-level goals when it comes down to everything. And those top-level goals break down into provisioning of servers and hardware and infrastructure level stuff, deployment of software, and then further beyond that, the management of that infrastructure. Once we have the infrastructure in place, once we have our applications deployed, we need to be able to manage that infrastructure. So let's kind of talk about what some of this stuff means. So when I talk about provisioning, what I'm actually talking about is the physical. Nowadays, that's a little bit of the lines are a little blurred here on what physical means, but the physical provisioning of a server, the actual building of a server. So by show of hands, who in here has a data center on site, an actual NOC that you guys walk into? Cameron, I know you're lying. Okay, so in the old days, we used to have computers in the office with us. Things are a little different. I suspect that you will probably in your career find yourself in a place where you're working at a place that just doesn't trust the cloud, and you'll be responsible for potentially managing the physical provisioning of servers. So we're talking about the building of the server. Now this also applies to VMs, right? So if we're talking about working in like a vCloud or an ESX environment, we still need to build the server. It's done a little bit differently with mouse clicks instead of with your bare hands. But the idea of getting the server, taking it out of the box, racking it, getting the drive set up, getting the drive configuration configured in the BIOS, et cetera, et cetera. And then furthermore, once the server is actually built, and this applies whether physical or virtualized, then from there we need to create installation media that's appropriate for the server. And then, so that process can be something, there's a variety of ways, of course, to accomplish this. If you guys are in a small organization, maybe you burn a CD or a DVD like I used to do, not that long ago, embarrassingly maybe a little bit. If your organization is particularly savvy, maybe you guys have a Pixie boot that you get into and you can actually get the OS installation process started. But either way, you need to choose the OS installation configuration that you're going to be working with. And that's the process of creating the installation media. Once that installation media is created, then you have the responsibility of installing the operating system on the server, right? And this is a fairly straightforward process. I think everybody gets this. This is not DevOps. This is Computers 101. Now, the thing about this, though, is that if you are, so show of hands here, who works in a regulated industry like finance or insurance or anything like that? Okay, so a few people. So if you're in a regulated industry, this process can be more important for you because you may need to prove through diligence or compliance that you can actually reconstitute. You can actually go back through the process of reprovisioning the server twice if you had to, using with the same outcome, make it a functional process. So that's what we mean when we talk about provisioning. Deployment is the process by which we actually get our application onto the server. So once that server is provisioned, taking the software that we've written that we intend to run on that server and actually getting it over there. So somehow we need to get that package, that artifact of software over to the server, whether you SCP it or maybe you guys generate a package appropriate for the operating system and install it that way. Somehow it needs to get there and installed. And then we need to make sure that it actually runs there, right? So performing some manual or even automated smoke tests, something like that. And beyond that is the matter of when we're deploying our software, we have certain environment considerations. Now, environments mean a lot of different things these days. When we're talking about it in terms of server, we're talking about when we're talking about it in terms of deployment, what we're talking about is the environment configuration that our application needs and having that available on the server. So we're talking about having the application configured to talk to the appropriate database servers, having it configured for the right messaging host, SMTP hosts, et cetera, things along those lines. So an environment in this case would be like your application running in a development context and in an integration context or a production, something like that. And then finally, when we're talking about system administration, it comes back to this last goal of managing. We need to manage the infrastructure, right? Now, the onus of this usually falls to true IT ops guys. So if you're in a DevOps role, I would ask you to analyze whether or not or how frequently you actually follow through with the further management of the infrastructure once it's done. I would say traditionally people who I talk to who are in DevOps positions will go as far as the deployment of their software and making sure that it can get to the right places and running the smoke tests to make sure that the environment's configured properly. And then management falls to an entirely different group, right? So we're keeping that operations side of things alive, which is very unfortunate because we're more than capable of doing this stuff. And we'll talk about a little bit about what it means. But effectively, management breaks down to this really involves managing how users get access to servers and server resources and system resources. It falls to designing security protocols around who is authorized to interface with the servers and in what particular way, and when those authorizations are allowed to succeed or when they're not. So, you know, this is the kind of stuff that's very important for us as developers, I think, and it's something that we need to consider when we're thinking about how we manage infrastructure and the infrastructure that's supporting our applications. So the question probably right now at the front of your mind is some permutation of that which is on the slide. So what about Chef, Puppet, Ansible, CF Engine, Rundeck, Rex, SyncTool? whatever CM server configuration of the week is available. And it's a totally valid question. These are utilities that are designed to simplify the process of managing server configuration right down to and including the deployment of your application. And these are very important things, and they come from a really good place. They come from that place of recognizing that the ops side of DevOps is hard, right? And it's not something that we can just ignore. So putting those aspects of server configuration and deployment and even to some extent provisioning into a configuration utility makes our lives much easier into a programmatic construct because we like that kind of stuff. But they're really only part of the equation, right? And that's probably the most common misconception I think that people who are in DevOps roles have when I talk to them is that your chef or your puppet can be designed to run and manage your entire infrastructure, and I think that's not really the case. And they certainly aren't perfect. Most of these projects, I would say, have gained extreme popularity and market share just really by sucking less than actually going out and doing the work yourself. And that's probably a good thing, right? So we want this process to suck a lot less, and they're coming from that place, and we want to support them in that role. But it should be understood, I think, that each of these solutions represent somewhat of a disjointed process when we're talking about the three higher level goals of provisioning, deployment, and management. And let's talk about that disjointed process. So when we go through the process of provisioning a server and getting it to a point where our software is ready for it, we basically have a very coupled process of going through and setting up the server infrastructure, getting it configured, right? RAID configuration, getting it set up, formatting the drives, et cetera, performing the OS installation, and then having it in a state where it's pre-provisioned, right? It's ready to rock and roll for all intents and purposes for our deployment to get over to it. Now, what the chefs and the puppets of the world do for DevOps is they pick up after this point. So we give it a minimum installation, effectively, a base image, right? That we think we're comfortable with usually. And then we go through our configuration management utility to get the server provisioned the rest of the way, right? So we get it the 10%, and we let the chefs and the puppet pick up the 90% of the rest of the way. Now the problem with that is that this is an agent-based type thing, right? So once we get that server set up, now we're relying on the agent to pick up and go off and do the rest of that. And that's maybe not such a great thing to have that be a disjointed part of the workflow. Understanding, I think, that tools like Chef require a pre-configured server or base image to be able to work will really highlight what the limitations of these things are. And we need to understand what the limitations are so that we can question them and we can continue to improve this process. So they rely entirely on some requisite work having been completed successfully for them to be successful. And that's kind of a big leap of faith, I think, to make, especially when they're not part of the original provisioning and configuration aspect. In addition to that, their agent-based nature, I think, requires that additional aspects of the environment, additional configuration detail needs to be in place in advance just for them to be successful, like networking, right? So we need to make sure that our agents can get back to their home base to find out what the configuration is, et cetera, et cetera. So this disconnect introduces risk, right? And if it doesn't complete successfully, then, like I said, we've gotten this thing to 10% of the way. If the configuration aspect doesn't get it the rest of that 90% of the way, then it can leave us in a spot that's sort of unknown to us, right? And even worse, something that I've seen happen is these will get you like 85% of the way, and you think you're good to go, and then only later do you find out that, hey, maybe something didn't work in the way that you thought it would. So I think that we can be smarter about this process, and I think that we can get to a place where this is a much improved experience for us, but it requires that we sort of change the way that we think about how we're doing things, right? So we need to rethink the way that we build and work with server environments. And some of that rethinking involves understanding what we need to consider out of environments, right? Disaster recovery is a really big part of this. So you have a very real need. If you're in a role where you're performing both the development and the operation side of things, you have a responsibility that you are going to ensure your business continuity in the case of a disaster, right? This is, or even in the case of just an emergency. If you haven't proven this to yourself, if you have actually not gone through the process of reconstituting your environment and ensuring that you have business continuity from nothing, then you're already working on borrowed time, right? So this is an exercise that you need to go through repeatedly to prove to yourself that you're able to do this, that the business is going to go on if something has happened. Again, if you're in a regulated industry like finance or insurance, your state or your country or whatever may actually require that you're capable of proving this, and you're capable of proving this without prompt, right? So they can bring compliance officers in and say, show me how your insurance or your software is going to continue to operate in the case of some sort of catastrophe or some sort of failure. So I used to work at an insurance company. I actually used to work at the worst kind of insurance company, a homeowner's insurance company, and in the worst possible place in Florida. And a big problem, and we had an on-site data center. We didn't have anything in the cloud, so all of our servers were in-house. And a big problem with being a homeowner's insurance company in Florida is that hurricanes can destroy you just as easily as they can destroy all of your customers, right? So we had to go through these exercises constantly of proving to ourselves and to proving to compliance officers, because the state of Florida requires that you're able to have business continuity, because you've made guarantees to customers, right? So you can't be hit by a hurricane and then say, well, we're out of business, right? So you need to be able to actually put your money where your mouth is when it matters. So we had to go through this exercise a lot, and disaster recovery is a very important aspect of that. In addition to that, being in a regulated industry, we also had to have a lot of fixtures in place for auditing purposes, right? And this is kind of important. This doesn't matter if you're in a regulated industry or not. This is just important for your own understanding of how things are happening in your environment and infrastructure. Putting fixtures in place throughout your infrastructure to audit exactly what's happening, right? This can help you get to a point where you better understand bugs, where you understand glitches in the system, that kind of stuff. Even if you're a startup, the ability to audit your infrastructure, this is a really smart idea. And especially, I would say, if you're in a startup. How many people here work in a startup? Okay, so at least a couple. Especially if you're in a startup, I think that this is a very important thing, because what you can do with this, by having these auditing fixtures in place throughout your infrastructure, you can prove to your investors and you can prove to the people who are putting their lives effectively on the line for your business to succeed, that you really have a grasp on what's going on. And that's a really good thing. You could set a lot of people at ease just by having auditing in place. In addition to that, when not if, but when you run into problems with your software, with your systems, you'll need to understand what's happened. I think all too often some bug will happen. It'll be difficult to reproduce, and we just say, not reproducible, or that doesn't happen all the time, so let's not worry about it. That's not a very good approach, I think, to when weird things happen. I think when weird things happen that you don't expect, those are the times when you should be really nervous, and you should take the time to pretty thoroughly understand what's happening there. So getting to that place where you really can understand what's happening with those things means that you should have some sort of forensics environment, some place where you can take the infrastructure on which your software is running, reconstitute it in a different environment, and be able to run back through that request track, and be able to reliably reproduce these bugs and understand exactly what's happening. It'll give you a really good insight into when those kind of glitches happen. So these are those environment considerations, and these are the things that we need to think about when we're sort of changing the way that we think about this stuff. And that comes to this idea that we need to be able to rapidly recover and reproduce an environment from configuration and archives alone. right? So we have the archives of our software. We have the configuration that stood up the server. We should be able to reconstitute that entire structure from that. Hopefully your code is under source control. Does anybody not write code under source control? Who has code? So nobody, right? Show of hands, how many people here use Git? Okay, so Git's pretty popular. How about your servers? Who version controls their servers here? For the record, nobody. So this is kind of a problem, right? We should be able to reproduce an environment from just configuration and archives, but we don't have our servers under source control like we have our software. If you're not 100% confident that you can reconstitute your server's configuration from nothing, then you're not really prepared for a real disaster. Even if you run through DR scenarios and you feel very confident with it, if you can't flick a switch that says, I'm going to reconstitute this environment, then it's not a real test, right? All that you're doing is proving that you can continue to be a software developer. It speaks nothing to the ops side of DevOps, right? This kind of gets us to an emerging idea, I think something that's getting a lot of traction and popularity, and it's that idea of immutable infrastructure. And in immutable infrastructure, every new version of a piece of software gets a new server. And the idea behind that is that servers are never reused or repurposed. They're totally ephemeral entities in the infrastructure. And what that means is that at a particular point in time, we can go back to a version of a software, and along with it, we can reconstitute what the server environment looked like that was supporting that software. This is really what the story of containers and Docker are all about, right? So I promised I would use the word Docker in my presentations, and I did, twice now, for the record. Docker kind of takes us to that point where, 3 times, I'm told 3 times, okay. Okay, 4th time. Docker kind of gets us to that point where we are thinking about the infrastructure in terms of the software, right? We're bundling the software into a container that we're going to ship, and that shipment that we're sending out is our infrastructure. It's a mindset shift to a software-defined infrastructure, right? And that's an important place to get if we want to exist in the modern world, right? So think about this. Think about it this way. We don't reuse jars and WAR files, right? If you guys write a new piece of software, you don't compile those classes and then take an existing jar file and copy your new classes into that. So why would you do that with your servers? Why would you take a persistent server and copy your software over to that instead of just developing a new one and sending it out with the software that you know is going to work with it? So a pragmatic strategy to building immutable infrastructure involves building deinstallation media that is going to be part of your provisioning process. And we'll be able to deterministically reproduce your infrastructure presence. And we can get to that point in a couple of ways. One that I think happens to be very good and pertinent to this talk, because we're talking about Groovy, is building your servers with Gradle. Going back to that idea that software being version control, but maybe not our servers, what we need to do is change the way that we build servers and the way that we think about building servers. And Gradle is a very powerful build tool, and we can leverage it to more or less that effort. We can treat the process of building servers as a programmatic operation. So we can understand the process by which servers will be constituted, and we can write software that's going to basically automate that process for us. The basic idea in this paradigm is to ensure that once an OS has been installed in a server, it's 100% good to go, right? So we don't have that disconnect anymore. Everything can be really tightly put together. So when we were talking about, when I showed this slide earlier, when we're talking about configuration management solutions for server provisioning, that represents that disconnect there, right? Because then we have to have the agent take over and go forward with it. When we're talking about building our infrastructure programmatically, what we're talking about, sorry, I shouldn't have switched off of that. What we're talking about is stopping at that pre-provision. Pre-provision now means fully provisioned. This is not 10% anymore, this is 100%, and there is no disconnect in that process. So Gradle can get us a good amount of the way there because it is such a powerful build tool, right? And it has a lot of capabilities for us to extend it in ways that I think it was never really intended to be extended, but it lets us do that, right? And that's a pretty cool thing. So there's no disjointing in this process. Everything is good to go once it's installed. And in that respect, the archive that we have generated from the build of a server is the installation media, is the artifact by which we can reconstitute a server. So for that, to accommodate this, I've written a plugin for Gradle. And it's called the provisioning plugin. And you can find it on my GitHub. So basically, the provisioning plugin is effectively designed to expose a DSL into the build script that you can use to outline what your server configuration should look like, and where it'll get some base installation media. You set a root password, you set partitioning details, et cetera, and then you can set the packages that you want to have installed, right? So in this example, what I'm showing you here is attaching a base URL repository where the OS packages will come from, an internal repository where we can get our own software, groups of software, and then our own versions of the software. In addition to that, with the DSL, you can put in post-installation scripts so that you can go through and further customize your server. And the cool thing about this is that this exists inside of a version-controlled thing, right? And you can treat it much like you treat your software today. Yeah. So this can kind of get us to a place where we have continuous integration with our software. We have continuous delivery with our software by packaging it and getting it ready to go. And then we can further get to continuous provisioning of infrastructure and continuous deployment of that infrastructure even further. So a provisioning and deployment job through CI might look something like this, where we have a web app that we're writing, that we're working with. We go ahead and we build it. That kicks off a provisioning and deployment job where we build our server infrastructure, which then chains off to some smoke tests to make sure that our environment configured properly. And then further on, if those pass, then we can get to a point where we have a production deployment. So I'm going to show you guys real quick the process of building a application. And for this web application, what I'm going to show you guys is building a web application from Ratpack, a simple hello world. This is not about Ratpack. This is more about just understanding that we're generating an artifact, right? A web application artifact, and we'll be putting it out on a server. So here I am. I wish I knew how to make this full screen, but I don't. So here, what I'm doing is I am, yeah, it's a video. Oops, okay. So here what I'm doing is I'm just generating a build script for a Ratpack web application. And this is kind of an old version, so in my talk at 2:30, I'll be covering the newer versions of Ratpack, which are far more compelling. But basically showing you the process that we're setting up just the infrastructure for an application to be built, right? And when this is done, I'll demonstrate as part of this actually creating and producing the Hello World web application. We'll pull it up in a browser, make sure that it runs in local development mode, and then I'll show you guys how we can utilize the provisioning plugin to take this web application that we've generated and put it onto a server. Now, the reason why I'm using Ratpack is because Ratpack is, well, I'm a little biased, but Ratpack also has the capability to be packaged into a fat jar, where we can just send it off to a server. It's an executable jar. It's runnable. It makes it very easy to get it to go, right? And also, Ratpack is screaming fast, so it's really great for demos. So I've written the application. It's a simple hello world. Starts up on port 5050. And you can see when we do this, we get a hello world. That's exactly as we would expect. That's kind of what it comes down to, right? Now that I have my web application built, now it's time to also build my server infrastructure along with that. And for that, effectively, this comes back to, I'll make this a little bigger. Can you guys see this okay?
The red's hard to read.
Red's hard to read? Should have thought of that. Let's see. Let me see. Whoops. Okay. Here, I'll try to make it a little easier for you guys. No, definitely not that one. Yeah, here we go. Okay, so what I've done here is I have the, and everyone can see this okay, a little bit bigger. Okay, so what I've done here is I've taken, so before I started with the Rat Pack Gradle, I've applied the provisioning plugin to this, in addition to some other things that I'll show you guys, or we'll talk about a little bit. And this has given me this provisioning block here, where I've defined the configuration for the server environment in which this software will run, right? So I have the base installation image. What the provisioning plugin does is it pulls down a base installation media, which is just effectively an ISO Linux bin, and it unpacks that, creates a kickstart file based off of your configuration here, and then repacks it, and then packages it back into an ISO. And that basically allows the ISO that's generated to be bootable media that'll perform an unattended install. And it'll do it in an automatic way. I won't talk about this right now, but again, exactly as the example that I showed before outlines, we have networking configuration, we have partitioning, and then we have some packages. And as part of this package, what I have is my web app here, right? And my web app is this web application that we're working with. So I've defined that name. I'm turning off IP tables because I'm a network security expert. I'm adding my web application to the startup, et cetera, et cetera. I've added some additional stuff to this build script. I've added the Nebula Gradle OS package plugin that will, this is something from Netflix, Nebula plugins. There are a bunch of Gradle plugins out there. This will allow you to create an OS package. So jar and war, these are insufficient for server environments, right? We need to package our software into a packaging structure that the server will understand, right? So we need to put it into Debian or RPM format, something like that. So I'm putting it into RPM format, which is good for CentOS. Which is what we're using in this example. And then I've also added an SSH plugin to this so that I can actually go ahead and publish it. I've added a publish task to this, which is going to push it to a remote Yum repository, which I have configured as an extra in this. So during the process of provisioning the server, it's going to reach out and install all the appropriate software. So this is that idea that we have configuration, we have archives, right? So we should be able to reconstitute it. In addition to that, now our server configuration is part of our version controlled software, right? It's part of the software project, which makes a lot of sense for it. And if we So what I'm going to do is I'm going to produce the fat jar, the runnable jar. I'm going to build the RPM from the fat jar. I'm going to publish it, and then I'm going to provision a server. Now again, the provisioning plugin is all about building the installation media, which will be used for provisioning your server. In addition to that, it has continuous deployment capabilities. It has hooks for for being able to reach out to deployment environments. Right now, it's just VirtualBox and AWS, but it could be easily adapted for basically, I think, any target runtime environment, or any target provisioning environment, I should say. So what I've done here is I've created the fat jar, I've built the RPM, I've published it, it's ready to go. Now I'm going through and I've created the installation media here. I've downloaded the install image, I've generated the kickstart, I've assembled the install image, now I'm provisioning it to VirtualBox. And you can see, as part of this build, a VirtualBox instance started up. It's attached the ISO to the VBox VM, and it's going through the unattended installation of this server. And it's getting started now. And what we'll see is that it's configuring the installation of the server. Skip through a little bit of this. And it's getting into starting the installation process, and it's getting into installing all the packages that we have, right? So this is that idea. We're not taking the server to 10%, we're taking the server to 100%, right? By the time that this is done, I want my server to be completely provisioned. I want my software to be available as part of that. So I don't think that we need to, unless you guys want to watch packages get installed. No, okay. So we'll skip through a little bit, and whoops. What I'll show you here is that when we get to a point where we have all of the OS packages installed, now we're installing my web application, right? Which is what we packaged as part of that build. So we built the fat jar, we built the RPM, we pushed the RPM up, and now we're at the point where we're actually installing it on the server. And this means that when the server starts up, it's going to come pre-configured with our application. And because we put those hooks into those post-installation hooks into the build process, it's also going to start up automatically for us. So when that's done, the VM will reboot, and it'll go through the first boot process, which we don't need to have any interaction with, and we'll get to a point where we can actually log in. We'll grab the IP address off of it, and we'll just validate that our software started up accordingly. And that's exactly what I'm doing. I know it's a little hard to see, but I'm just doing an if config, grabbing the IP address, switching over to Chrome, typing in that IP address, and just validating that the software started up exactly as we expected, port 5050, and yes, we have hello world. I refresh it a few times just to prove. So now we have a server that was built as part of our software packaging process and is 100% good to go. So this is a good step toward immutable infrastructure, right? Because we get a server every time that that our software is built, and we know that it's going to work. So there's no additional stuff that needs to happen with that. So that's pretty cool, right? And again, we can chain this together through CI. So we can say that we're going to go off and do all of this in basically one fell swoop. So that gets us through provisioning. That gets us through deployment. But then there's still this overarching issue of management, right? Once we have this stuff up and running, somebody's got to manage it, and we have to have those fixtures in place for being able to audit the environment, for being able to have those security protocols designed and configured to make sure that everything is good to go. We can use Groovy to help us out a lot with this. So I'm going to show you guys an example here of doing some authentication hacking with Groovy. The basic idea behind this is that we don't necessarily need to have those ops people be in charge of this aspect of management for us, right? And especially if we're moving to a point where we have a software-defined network, we can get a lot of flexibility in this area. So I'm going to talk a little bit about Linux here. And Linux's authentication mechanism is built on PAM. PAM is the pluggable authentication module. And PAM is great because it gives system administrators a lot of flexibility in how they ascertain whether somebody is allowed to log in, where they get account details, protocols for password changes, and session interactions, all those kinds of things. For the purposes of this discussion, we're just going to be talking about basically authentication. Some common PAM modules. If you guys work in an environment where you need to log into a server and you have some sort of centralized authentication, you are probably using something like an LDAP configuration or Active Directory. PAM has all of these inputs for being able to do that. And regardless of your organization, you're probably using one of these, something to that effect. So it kind of raises the question here of why not let the software infrastructure manage the server's authentication strategy, right? If we're moving to a software-defined network, why not let our centralized software system, where we're already managing user accounts, if maybe we're using Spring Security or something like that, why wouldn't we do the same thing for our box's authentication, for the server's authentication? So if we need to be able to log into it, we know that we can do that through a centralized mechanism that we're comfortable with. And we don't need to have a lot of bulky infrastructure around an LDAP server or an Active Directory server or Radius or something like that. So why not something that we're comfortable with? This is a Groovy and Grails, and I think Spring conference. So why not a Grails application, right? We know that we can write Grails applications. We know that we can configure Spring Security inside of Grails. How about when we log into the server, it reaches out to a Grails application that we've already set up, and we know that we're able to manage users through, and have it authenticate that way. So again, PAM's modular nature allows us to do that kind of thing. And we can do so using the PAM exec module, which will basically allow us to execute any arbitrary script when performing any aspect of the authentication sequence. So that authentication, getting account details, et cetera, can all be delegated off to some place of our choosing. So to facilitate that, we can go through and configure our server. And again, we can do this as part of the configuration so that we have to modify the login process or optionally the SSH process to say that we want to execute this when we're performing authentication. We want to execute this etc security on auth process, and we want to expose the authentication token to it so that we can send that off to our Grail server to provide access for us. And what this on auth script is doing is it's making a curl call out to our application on our port off to our controller. And what that controller is going to do is it's going to test the authentication and see if the user and password combination is known to the Grails application. And if it is, then we're going to return with a success. If it's not a success, we're going to fail the authentication. If it is a success, we're going to log them in. And in addition to that, we're going to create their structure on the box, right? So that they have a home directory and stuff like that. So what I'll show you guys here is not that video there. No, not necessarily. You could use expect and TCL to accomplish the same thing. I've used bash, but basically what this let me go back to this. So the question was this to get around using expect? Is that what you asked? No, not necessarily. So what you're, I see what you're getting at. No, this is not about remotely accessing the data. This is about so we need to be able to log into a server, say to a tail logs or something like that, and instead of having user configuration proliferated across all the instances, we maybe have a centralized location. That centralized location typically would be something like Active Directory or LDAP or something like that. What we're saying is instead of reaching out to one of those, reach out instead to our Grails script or our Grails application to see if that user is known in the Spring Security context. So when I'm actually performing the action of login, I want it to reach out to Grails instead of some other server and check that Grails says, hey, I'm good to go, right? So this is kind of moving toward that. This is kind of moving toward that idea of a software-defined infrastructure where our Grails application that we're very comfortable with and we know that we can configure and manage in ways that we're familiar with, much better than server infrastructure like LDAP or something like that. So does that answer your question? Okay. So basically, I have a very, very extremely simple Grails 2.4 app here. And what I've done in this Grails 2.4 app is I've added nothing beyond the Spring Security Core 2.0 RC4 plugin. And this will give us those dependencies that we need for setting up user accounts. And then inside of my Bootstrap, I've created a role, I've created a user, and I've created a user role, right? We know that we need to do this when creating new users with Spring Security. And beyond that, the only other thing that I've done is I've created an auth controller. And what this auth controller does is it exposes one action, one endpoint. And this action creates, based off of the parameters of user and password, it creates a username password authentication token. And we're going to use the Spring Security Authentication Manager to try to authenticate that token. So that those details that we're passing back from the login process, we're going to throw off to Spring Security and to check it. If it fails with the bad credentials exception, then we're going to respond with a failure. And if you guys remember that script that I just showed, if it's not success, then we exit immediately. If it is success, then we permit them onto the box. So if we succeeded, then we're going to just render success back to them. So based off of my Bootstrap here, I have, again, I'm a network security expert. So I have user is the username and password is the password. Trust me. I'm in charge of important things. So I have a, let me see, where did that go? I have a box. Let me just, oh, right. So that's probably not going to work too well. All right, so I have a server here, which we'll do our best. That is very difficult to see. Can you guys see this? OK. So I have a server here. And if I look at that on-auth script, what I've done is, this is exactly the script that I've shown you, right? So this is what we're going to use to, I know it's probably a little hard to read, but this is what we're going to use to reach out to the Grails application on port 8080 to get the access token. If we get back that success, again, we're going to add the user to the box, and we're going to permit them to log in. That's configured through that pam.d/login. That's permitted through here. We're saying, again, I'm a network security expert, so we're saying it's sufficient if we get back a yes or no out of this thing. That's good enough to let us onto the box. And we're using that PAM exec module to invoke that script to go off and do that. And I'll demonstrate that for you guys here. OK. One sec. Let me just move this back over real quick. I didn't consider the conference Wi-Fi, maybe not wanting me to, maybe not wanting my VMs to connect to it. Let me see if I can get them on there real quick. But here, I'll go ahead and fire this thing up in the meanwhile. And we can demonstrate at a minimum that we can get to that endpoint, and that endpoint is going to work as we expect. What the heck? What's wrong with this? Shoot. OK, so we have the Grails application fired up. It started up on port 8080 here. And if we open up a browser that we have, we go to 8080/auth, and we say, whoops. So we got a failure, right? Because I didn't supply anything. We say user equals user and password equals password. We get a success. So we know that that part's going to work. which is great. And I'm just going to try to reset this box real quick and see if it'll come up on the network. Whoops. Because I want to demo this for you guys. Does anyone have any questions meanwhile? 192.168.157. That's coming. Yeah, so I think it's having problems starting onto the network. Bummer. The basic idea there, though, is of course it'll reach out to the Grails application. It'll perform that authentication, and we can use that as sort of our structure for getting authentication and authorization in there. Okay, so that gets us one of the management aspects, right? And that can also we can kind of utilize this structure here. You can imagine a fairly primitive example of reaching out to a Grails application and asking good or bad for a user logging in. We can expand that a lot to get us to the point where we're tracking and where we're auditing users who have logged in, and we can do that through a web interface and through a structure that we're comfortable with through Groovy, right? Because of Grails. And that provides a lot of those aspects of management that we know that we need to cover, which is great. So there's a little bit more to this, right? And that's the authorization stuff. So authentication is easy. We can reach out to Grails. We know that we can do that. PAM enables us to do that. We can start auditing. We can start tracking through our Grails application. Then there's the aspect of authorization. So what users can access what resources at what times, right? And to facilitate that, we need to do a little bit of kernel hacking, and we can basically integrate Groovy into our workflow here by providing a DSL, some structure of saying anytime that some operation is performed on the server, we want to check with our Groovy application to see if it's cool to go forward with that or not, and we'll send the parameters of the operations over to that Groovy script to make use of it. So. We need to modify. Yeah.
Sorry about that. I just came in late, but just very briefly. First aspect you talked about was user authentication.
Yeah.
And how does it tie up with the system admin? I mean, the whole. What is the idea of tying in system admin? How does it help?
Okay. So the question was how does enabling authentication on the server help with system administration? Yeah, at the beginning of the talk, we talked about aspects of system administration and things that we know that we need to cover. In the effort of management of server infrastructure as system administrators, one of the things that we need to be able to do is maintain user accounts and access to servers, right? So. This is a continuing effort. This is an ongoing effort that needs to be persistent as you go forward. So designing your systems in a way that they can talk to your application, your web application, your Groovy application, to check to see if it's okay if a user logs in. That's kind of where that's coming from. So back to this. So basically, we have the authentication down. Now we need the authorization. We need to be able to design security protocols around who can access and at what time, and also apply more auditing fixtures, right? So getting into the server is one thing, right? We can track that through the authentication mechanism that we just talked about, and we can log that, and we can make use of that later if we need to. But then what do they do once they're on the server, right? This is another aspect that we need to know about. And we can manipulate the Linux kernel a little bit to ask our Groovy scripts every time that you do something, whether it's A, it's okay for them to do that, so that's designing security protocols, and B, we can go off and log that someplace central. We can reach out maybe to another Grails application to store that in a database somewhere, and to put that data together for an auditor or something like that, right? But we have a big problem when we're futzing with the Linux kernel, and that is that we can't have a JVM in the kernel. That's ridiculous. And quite frankly, there's not really much that we can do when we're in the kernel context, when we're in the kernel space. So we need to have a way. We need to have a way when we're when we're inspecting kernel operations, when we're looking at what a user is doing on the server at the kernel level, to get it back to our Groovy script. And there are a couple ways to accomplish this. So Groovy and the JVM run in user land. The kernel module that we'll be talking about that'll be inspecting all this stuff runs in the kernel space. They have their own memory mappings. They have their own memory spaces. They have their own proc tables, things like that. They don't share any of this stuff. There are a couple strategies for bridging the gap of kernel processes to user land processes. One of them is through procfs, if you guys are familiar with that. We can basically mount a new procfs point from our kernel module, and then we can have our Groovy script ask us for details about it. We can publish details about what users are doing. That might be a good solution for the auditing aspect of it. Another aspect, or another mechanism for getting communication between these two spaces is via netlink. Netlink is essentially a networking protocol that we can write packets from kernel space out to user space. Userland applications can read that detail and respond accordingly, right? So it's just a networking protocol. The problem with netlink is that netlink and Java, there's not a lot of support there, so it doesn't fit very well into our Groovy world, unfortunately. So that's not really a great option for us. It's a great option if you have another C application. C applications are able to talk netlink fairly natively and make use of that. So this is like a raw socket type stuff. Another option would be memory map. So we could actually write a memory map file out to the file system somewhere and have our Java application read in that memory map file and actually read objects out of that. So we're effectively what we're doing from the kernel module. We'll be serializing data to the file system and then reconsuming it from the application. Now, you may know Java manages its own memory. So reading a memory map file and reconstituting objects out of that's not really a great option because it's not really able to work with that. So it would be just sort of introspecting this third hand there. However, another thing that we can do that actually seems to fit very well is we can talk over UDP. And that might not seem like the best of options, but if you consider that our user land Groovy process is running within the local stack, we don't need to traverse the network to get that detail out of there. So from our kernel module, we can actually write packets over UDP to a Groovy script that's listening on a UDP port for datagrams, and then the Groovy script can respond to the kernel module with the success or failure, and then further go on to track details about it. So let's consider a make directory request, right? And this is what we'll talk about here a little bit. We can use Groovy as a rules engine effectively for saying whether or not a user is permitted to make a directory or not. And in this case, what happens, so anytime that you execute the make dir command on a Linux box, effectively what it's doing is it's doing a syscall table lookup, looking for what the make dir command is, and it resolves to this nr make dir, and then it invokes the kernel's make directory command, which delegates off to the file system to actually go ahead and make the directory. That's part of the workflow. What we want to do instead is we want to put Groovy in the middle of this thing to say whether or not it's okay to make that directory or not. So to accommodate this, what we want to do is we want, when the make dir is invoked, we want it to go to the syscall table to look up what is the actual symbol for that make directory call. And then what we want to do is we want to override that location within the kernel to be our own code that's going to make a UDP call out to a Groovy script that we have. It's going to ask that Groovy script, is it OK for this directory to be created or not? If it's not, we want you to respond with a failure. Well, we actually just want you to not do it. If it is OK, then we want to delegate back off to the kernel to actually go ahead and invoke the original make directory command. And that'll, again, create that off of the file system. And what we can do with this is we can put pretty powerful rules inside of Groovy for doing that kind of stuff. And we could build DSLs around this concept of access control, right? And again, in a more robust sense, we can perform auditing and tracking and that kind of stuff. But for this example, what we'll talk about is just overriding that make directory command. So I will bring this over here. Can everyone see that? OK? OK. So I have a server here. This is nothing tricky, right? This is a basic 2.6 kernel. I'm running CentOS 6.5 here. And what I have in this directory, Dan rules, which is true, I have a kernel module, right? And has anyone here written kernel modules for a living or anything just for fun? Yeah, OK. So kernel modules, this is a fun way of doing things. Let's see if. Yeah, so basically, we create an injection point. When the module is initialized, we can go off and do some stuff. All of this is more or less boilerplating code a little bit. Everything except for this line, these two lines, right here. And what these two lines are saying is, I want to capture the original make directory command, and I want to store that. So I'm going to the syscall table, and I'm looking up that make directory command. I'm storing the symbol for that. And then I'm overriding its value, the value for the kernel's make directory command. And I'm pointing that over to new make directory. And new make directory is something of mine. And that exists up here. I'll jump to the top. It's a lot of code. Whoops, sorry, that's not where it exists. That exists here. And this is so it needs to be an ASM link to get it into the syscall table. But effectively, what this is doing is it's taking the inputs of a path and a mode, and what we're doing is we're gonna perform an RPC call with the provided path, and this RPC call is going to reach out to across the socket over UDP to our Groovy script, and ask it, is it OK? So we're listening on port, or we're listening on some prescribed port, but on the local host interface. And we're going to send that detail over the wire. And our Groovy script is going to inform us whether or not it's OK to proceed or not. And that Groovy script looks something like this. So this is just something very simple, right? And we're starting a thread. We're looping, checking for packets on the UDP the UDP port that we're listening on, which is 5555, and we're taking and grabbing the input, which is the directory command, and we're saying if the directory is called rootkit, then we don't want to let them do that, right? If it's not called rootkit, it's OK, but we don't want hackers to be able to create rootkits on our server, so forget it. And as we all know, hackers create rootkits in directories called rootkit. So, so we can go ahead and log in over here. So what I'll do is I'll just real quick, I will remove the intercept module. So that has exited. I will insmod. I'll insert the module. So it's initialized, and we can tail the system logs to verify that it has initialized. We know that it has because I'm writing out some debug statements there. And over here, we will go ahead and start up that udp.groovy. So looks like we already got a request, probably from some background operation. And if I jump back over here, what I'm going to do, this is in a different terminal. I'm going to just validate that I don't have a directory called rootkit. I know that I don't. And if I go to make directory rootkit, what's happened is it's made the call over to our Groovy script. And what our Groovy script has done is it's looked at this thing and it's responded with a no thanks, right? And that's a special message to our kernel module. And our kernel module knows that no thanks means no thanks, and we don't want to do it. And if we look here, we can see it wasn't created at all, right? And just to prove to you guys that I'm not cheating, we will go ahead and remove that. And that exited. And if I create a directory called rootkit, we can see there's actually a directory called rootkit in there now. So it actually is delegating. It's actually not performing the hijack anymore. So we're making those calls over the wire to a Groovy script. And this can be a pretty powerful faculty in the effort of system administration, because now we can design security protocols in a really robust way, right? And perform auditing and tracking, all that stuff that we know that we need to do. So that's a pretty cool thing. So the question was, can I delve into, sorry, ask it again? Oh, over, yeah. Yeah, it's true. It's very true. It's a contrived example, for sure. In practice, we would probably want to have some sort of secure tunnel between them. But I think that the goal that we always want the kernel to ask out, that makes a lot of sense, right? And we don't want somebody to snoop in the process. Probably with certificate exchanges. So C is really good at using OpenSSL, or well, I shouldn't say OpenSSL, some form of SSL, right? We probably don't want to use OpenSSL, but that kind of relationship can happen between them, right? So we can authenticate the peer in advance. Same way that you do any kind of networking security, I would say. That's probably the best example. I think it's kind of a good solution for the auditing aspect, probably more than anything, and just in the form of like trust relationship, right? So we want to track what people are doing, not for the purposes of well, maybe for the purpose of getting them in trouble, but moreover, we want to know what happened at what time so that we can identify why a system's performing in a certain way.
So, one more question.
Yeah, sure.
So like what you did initially when I first asked the question like specs, I misunderstood what you're doing.
Yep.
What you're doing is you're making sure that all PAN calls actually go to the co-op provider from the Groovy controls, right? So that all of like the Linux user authentication is really whether that user account is authenticated on Groovy.
Yep.
Or is there a way to also do this from the perspective of this exchange you just showed, whereby it would pass in whichever the user account is that was making the
Performing it.
Groovy,
Yeah.
that would close the loop and solve the security problems?
Very much, yeah. Yeah, that would totally be possible. I guess the point here is the well is bottomless, right? The possibilities in this case are very broad, right? So there's a lot of stuff that you can do, and it makes it pretty cool. For us Groovy developers, this isn't limited to Groovy, right? We could do this with anything, to be honest. Groovy happens to be a really good choice for doing this kind of stuff because we can build DSLs and have people who are actually non-Groovy Groovy developers, I think, defining those ACL rules, which would be the ultimate goal. So in that UDP example that I showed, that's some code that is just very straightforward Groovy, checking yes or no. In the future, what we might want to have is a centralized location where some security council or committee or something like that can actually define what those rules are for the full scope of the infrastructure. And we can build a DSL on top of Groovy to do that. And that's where Groovy's value in this really plays out, I think. Does that answer your question? Cool. So some of the other considerations that we might have for kernel hacking, like I said, the possibilities are very open for where we can integrate Groovy in the kernel, right? And part of that is that the kernel is so modular, it really gives us easy capabilities of hooking in. Intelligent packet inspection, like for IDS purposes, we can get into that via Netlink, or Netlink, yeah, with Netlink. So we could write a Netlink module that would be responsible for delegating off to a Groovy script, asking the Groovy script, is it okay for this packet to be there? Alternatively, we could actually manipulate the network. So a packet gets sent over to our Groovy script, the details of the packet are inspected, and then we respond to another kernel module that in turn will manipulate the packet in a prescribed way. So maybe we manipulate the headers or the routing protocol, something like that. And it's a much more pleasant experience to program these rules into Groovy than into a C module, right? So that's kind of the goal. We want to be smarter with this stuff and better at it. And in that same effort, packet tagging, external tracking, being able to correlate. So this will kind of get us to that point where we're actually able to correlate the flow of traffic throughout our infrastructure, right? If we can look at it and we know an application is deployed on a particular server, right? Because we've provisioned the server along with the software, we can actually tag packets destined for that application with a particular header or something that we can later inspect. We can track them and inspect them. So when we have a glitch in the system or when we have a bug or something weird is happening, we know what the packets are that have gone through the process. We can correlate all that stuff together so that later on when we go to that forensics environment, when we reconstitute this in a test network or something like that, we know exactly all the details that have gone to that application. We can replay the whole thing. That would be another way to do it. And that also kind of comes down to user and application metrics gathering, right? That's it. That's all I got. Questions, comments, concerns, snide remarks? Dave. Right. For actually pushing them out. So like I said, the plugin itself actually has hooks for performing deployments, which I don't have shown here, but I do here. So so in this case, what I've done is I've chosen to deploy this to VirtualBox. The provisioning plugin also has the capability to deploy to AWS. We could additionally add a deployment endpoint for something like vCloud or I don't know, what's the hip deployment endpoint today? Cloud Foundry. There we go. So maybe not Cloud Foundry because we can't deal with ISOs there, but basically anywhere that we can deal with an ISO, that can be a target deployment. So Netflix, you pointed out, uses Asgard. We use Asgard to deploy AMIs. AMIs are effectively the image that we're sending off. So with the provisioning plugin, we produce an ISO. At Netflix, we produce an AMI. It's the same concept of immutable infrastructure, just with a different medium. I probably tend to prefer the idea of an ISO over an AMI because we can take an ISO and send it anywhere, right? And that's kind of the benefit there. Does that answer your question? Okay. Yeah.
So what do you have to have in mind for the box if you have what just standard virtual box?
Yeah. So they also have an API server. So you have to start their SOAP server, which is just VBox web serve, and that'll allow the that allow the provisioning plugin to talk to it. So that just ships with every VirtualBox distribution. So the real value, I think, in all of this is that you can fire this up basically in any virtualized infrastructure, and you can run smoke tests against your app. I think that's a real benefit there. So actually get real 100% truly functional tests running in a contained environment. Yeah. Yeah, exactly. Actually, it's published to JCenter, which is the best. So you can just pull it in as an artifact into your build script. And 0.4 is the latest, and that has all the up-to-date stuff. All right, thanks a lot, guys. Appreciate it.